Quantum Foundations of Reality, Unlocking the Mysteries of the Cosmos. In our quest to understand the universe, we have often looked to the stars, to galaxies far beyond our own, and to the mysterious forces that govern cosmic expansion. But while we are looking outwards, there is also an equally fascinating and confusing world right under our noses, the world of quantum physics. On the smallest scales, the universe functions according to completely different rules than those we observe in our everyday lives. Quantum physics is the theory that describes the strange, counterintuitive behavior of particles at the subatomic level, where uncertainty reigns and particles can exist in multiple states simultaneously. But how does quantum physics help us to understand the potential for life beyond Earth? In this chapter, we explore the fundamental principles of quantum mechanics, the way particles interact at this fundamental level, and how these principles could open up new possibilities for the existence of life elsewhere in the universe. One of the most famous experiments in the history of quantum physics is the double-slit experiment, which showed that particles such as electrons can act both as particles and as waves. In this experiment, a particle beam is shot through two narrow slits onto a screen. If particles behaved like tiny billiard balls, we would expect them to create two distinct stripes on the screen where they have passed through the slits. But when scientists observed the results, they saw an interference pattern, a series of light and dark streaks, as if the particles had passed through both slits at the same time and interfered with themselves, just like a wave. This phenomenon, known as wave-particle duality, is one of the fundamental concepts of quantum mechanics. It suggests that particles do not have fixed positions until they are observed. Until then, they exist in a superposition of all possible states. This strange property has profound implications for how we understand the universe because it reveals a fundamental uncertainty in the behavior of matter at the smallest scales. In the context of the search for life in the universe, quantum superposition challenges our classical notions of existence. If particles can be in several states at the same time, could entire systems or even life forms exist in several configurations? Could life in distant regions of the universe be governed by quantum mechanical rules that are radically different from those on Earth? One of the most baffling phenomena in quantum physics is quantum entanglement, a phenomenon famously described by Albert Einstein as spooky action at a distance. When two particles are entangled, their states are connected in such a way that the state of one particle is immediately known by the other, regardless of how far apart they are. If you measure the state of one particle, the other particle knows the result immediately, even if it is light years away. The idea of entanglement challenges our understanding of space and time, as it suggests that information can be transmitted instantaneously between distant points in the universe. Although entanglement has been experimentally demonstrated in laboratories, its full implications are still being researched. Could quantum entanglement be the key to communicating across vast distances in space, possibly allowing us to connect with intelligent life in distant galaxies? If entanglement allows particles to be connected across light years, the question arises as to whether life forms or advanced civilizations could use this phenomenon to communicate instantaneously across the cosmos. In fact, some scientists speculate that quantum entanglement could play a role in biological processes, such as the transmission of information in living cells. If true, it could suggest that life elsewhere in the universe could also use quantum mechanical phenomena to survive, thrive, and even communicate over great distances. Another cornerstone of quantum physics is Heisenberg's uncertainty principle, which states that certain pairs of physical properties, such as position and momentum, cannot be measured simultaneously with perfect accuracy. The more precisely we know the location of a particle, the less we know about its momentum, and vice versa. This fuzziness is not just a limitation of our measuring instruments, but a fundamental property of the universe at the quantum mechanical level. The uncertainty principle implies that the universe is inherently unpredictable at the smallest scales. This has profound implications for our exploration of the cosmos and our search for life beyond Earth. If the universe is governed by fundamental uncertainties, this suggests that life could emerge in ways that are unpredictable and unique to each corner of the cosmos. There could be regions of space where the quantum conditions are favorable for the emergence of life, in ways that we cannot imagine on the basis of classical biology. Could life in the universe be much more diverse and strange than we expect, shaped by the probabilistic nature of quantum mechanical events? And how does this uncertainty affect our search for extraterrestrial civilizations? The uncertainty principle reminds us that the universe may hold secrets we have not yet discovered, and that life beyond Earth may exist in forms beyond our current understanding. Quantum tunneling, a path to life? One of the most remarkable and counterintuitive phenomena in quantum physics is quantum tunneling. In classical physics, if a particle does not have enough energy to overcome a barrier, it cannot pass through it. But in the quantum world, particles can sometimes tunnel through barriers, even if they don't have enough energy to do so in the classical sense. This process is crucial for many quantum systems, including the nuclear fusion that powers stars like our Sun. Quantum tunneling also plays a crucial role in certain biological processes. For example, it is involved in enzyme catalysis, in which enzymes accelerate chemical reactions in living organisms. This has led some researchers to speculate that quantum tunneling could be crucial to the processes of life, possibly enabling the emergence of life in environments where classical chemistry alone is insufficient. If quantum tunneling is crucial for life on Earth, it could also be crucial for life elsewhere in the universe. Could life forms in extreme environments, such as deep inside gas giants or on the surface of distant moons, rely on quantum tunneling to survive and thrive? The ability of particles to tunnel through barriers could allow life to exist in places we would otherwise consider inhospitable, expanding the range of environments in which life could emerge. Let's try a thought experiment for a moment. What if life outside the Earth did not follow the same biological rules that we observe on Earth, but instead operated entirely within the framework of quantum mechanics? In this thought experiment, life forms are not composed of ordinary matter, but are quantum beings that exist in a state of superposition, entanglement, and uncertainty. These quantum life forms could not have a fixed, defined form. Instead, they could exist simultaneously in several states and only change into a specific form when they are observed or interacted with. They may use quantum entanglement to communicate instantaneously across great distances and share information in ways that transcend our understanding of space and time. Could these quantum civilizations be observing us right now, undetected by our classical sensors and instruments? And if so, how could we ever get in touch with them? Would we have to develop new technologies that function according to quantum mechanical principles in order to discover these beings and communicate with them? This thought experiment highlights the possibility that life beyond Earth could be much more complex and alien than we expect. The rules of quantum physics open the door to new ways of thinking about life in the universe and suggest that we need to expand our search beyond the traditional biological forms we are familiar with. Quantum physics may not only be important for understanding life on distant planets, it also plays an increasingly important role in our understanding of life on Earth. The emerging field of quantum biology investigates how quantum phenomena influence biological processes, from photosynthesis in plants to the way birds use the Earth's magnetic field to navigate. One of the most striking examples of quantum biology is the efficiency of photosynthesis. In plants, light-absorbing molecules called chromophores transfer energy through a process that appears to involve quantum coherence, with energy traveling through the system as a wave, exploring multiple pathways simultaneously. This process enables plants to capture sunlight with incredible efficiency by using quantum principles to optimize energy transfer. If life on Earth already utilizes quantum mechanics, this raises the intriguing possibility that life elsewhere in the universe may rely even more heavily on quantum processes. In extreme environments, such as the surface of distant exoplanets or the subterranean oceans of icy moons, quantum effects could be the key to survival. Quantum biology is still a relatively young field of research, but as we learn more about how quantum mechanics affects life on Earth, we could gain new insights into how life might emerge and evolve in the wider universe. The interface between quantum physics and biology could be the key to understanding not only our own origins, but also the potential for life throughout the cosmos. Quantum mechanics and the multiverse, expanding the possible. In the world of quantum mechanics, the idea that particles can exist simultaneously in multiple states, a phenomenon known as superposition, has fascinating implications. One of the most fascinating interpretations of quantum mechanics is the many worlds interpretation, which was first proposed by the physicist Hugh Everett in the 1950s. According to this theory, every time a quantum event with multiple possible outcomes occurs, the universe splits into different branches, with each branch representing one of these outcomes. This means that every possible version of reality actually exists in parallel universes. In this multiverse, there is not just one version of you, the Earth or the universe. Instead, there are countless versions, each with small or dramatic differences. A universe could be almost identical to ours, except for one small detail, like a single atom that is in a different place. Another could have evolved with completely different physical laws, leading to a completely alien universe in which the concept of life as we know it does not apply. But what does the many worlds interpretation mean for the search for extraterrestrial life? If every quantum possibility leads to a new universe, it follows that intelligent life must exist in some universes. In fact, if the multiverse is real, there could be an infinite number of universes in which life has emerged in countless forms, some familiar, some unimaginable. Let's pause for a moment to really grasp the scale of the multiverse. If the many worlds interpretation is correct, every quantum decision, from the flip of a coin to the outcome of a supernova explosion, creates a new branch in the multiverse. In one universe, a civilization could develop faster than light technology, explore distant stars, and make contact with other intelligent beings. In another, the same civilization might never get beyond simple tools, leaving their planet without any technology. The impact on the search for life is profound. While our universe may seem vast and mostly empty, the quantum multiverse is full of endless possibilities. Intelligent civilizations could exist in other branches of the multiverse and live in realities that are only a quantum decision away from our own. Could we ever communicate with these other universes? Current physics suggests that this is impossible, but the very idea that these universes exist, with all their possibilities, opens up new ways of thinking about the potential for life beyond Earth. In some interpretations of quantum mechanics, particles can even interfere across different branches of the multiverse. If this is true, it raises the question of whether advanced civilizations in parallel universes might one day find a way to cross the quantum barrier and bridge the gap between realities. Why are we here? The idea of the multiverse is also related to a concept known as the anthropic principle, which attempts to explain why our universe seems so perfectly suited for life. The anthropic principle states that the universe appears so finely tuned for life because we happen to be in the universe where the conditions make our existence possible. In many other universes, the laws of physics could be completely different. Stars could not form, atoms could not hold together, and life as we know it could be impossible. But out of the infinite possible universes, we exist in one in which the conditions are just right for intelligent life to develop. In this sense, our existence is a consequence of the multiverse itself. Life had to arise in at least some universes. But what about life in other universes? Could the fundamental constants of nature be different in such a way that life exists, but in forms that are completely alien to us? Perhaps in some universes, life thrives in environments that would be lethal in our universe, relying on exotic forms of matter and energy to survive. The multiverse opens up an almost infinite range of possibilities and suggests that life could exist in forms that we cannot even imagine. At the heart of the multiverse lies an even stranger concept: quantum foam, the idea that space-time itself is not smooth and continuous, but made up of tiny, ever-changing bubbles on the smallest scales. This foam exists on the Planck scale, far beyond the reach of today's technology, but could be the key to understanding how new universes are born. According to some theories, the quantum foam could be the birthplace of entire universes. Just as quantum fluctuations cause particles to appear and disappear in our universe, these fluctuations could create entire regions of space-time that evolve into new universes. In this sense, the multiverse could be constantly expanding, with new universes constantly emerging, each with its own unique properties and physical laws. If the quantum foam is the birthplace of universes, it opens up the possibility of new universes being created with conditions that enable the development of life. Could life in these universes use quantum foam to communicate or even travel between universes? Although this remains purely speculative, it demonstrates the profound implications of quantum mechanics on the nature of reality and the potential for life beyond our universe. Let's do a thought experiment. Imagine that a highly advanced civilization has developed the ability to detect and manipulate the quantum foam, allowing it to communicate across the multiverse. In this scenario, they could make contact with civilizations in parallel universes and establish connections that transcend the boundaries of space and time. How would this communication work? Perhaps it would consist of manipulating quantum particles in a way that entangles them across universes so that information can be exchanged instantaneously. This civilization could send messages into the quantum fabric of the multiverse, hoping to make contact with intelligent beings in other realities. What would these messages look like? Would they follow the same communication rules that we use, or would they rely on completely new principles of quantum information? And how could civilizations in our universe detect these signals? Perhaps we would need to develop new technologies based on quantum principles, capable of picking up the faint echoes of civilizations reaching out of the multiverse. Although this thought experiment pushes the boundaries of what we currently know about quantum mechanics, it opens up the tantalizing possibility that intelligent life is not limited to our universe, but exists in countless other realities, just waiting for us to find a way to make contact. Is quantum computing an insight into parallel universes? Quantum mechanics has already begun to revolutionize our understanding of computing power through the development of quantum computers. In contrast to classical computers, which process information in binary form, ones and zeros, quantum computers use qubits that can exist simultaneously in a superposition of 1 and 0. This enables quantum computers to perform calculations at incredible speed and solve problems that would be impossible for classical computers. However, some researchers speculate that quantum computers could do more than just process information faster. They could access parallel universes. According to this idea, when a quantum computer performs a calculation, it simultaneously explores several possible solutions by branching out into different parallel universes. The computer then selects the correct solution from all possible results and essentially decides on the best reality. Even if this idea remains speculative, it shows the deep connections between quantum mechanics and the multiverse. Could quantum computing be our first glimpse into the world of parallel universes? And if so, could it one day be used to explore these alternative realities in a way that goes beyond mere calculations? The development of quantum computers is still in its infancy, but as this technology advances, new insights into the nature of reality and the existence of other universes could be gained. Quantum computing could one day be the key to unlocking the secrets of the multiverse and opening up new possibilities for life beyond our own universe. The concept of the multiverse considerably expands the potential for extraterrestrial life. In our universe alone, there are billions of galaxies, each with billions of stars, many of which harbor planets that could support life. However, if the multiverse is real, the number of possible habitats is no longer limited to the stars and planets in our universe. It extends to an infinite number of parallel universes. Some of these universes may have evolved in a way that favors the emergence of intelligent life, while others are hostile to any form of life as we know it. In the multiverse, every possibility becomes a reality, suggesting that somewhere, in some universe, intelligent civilizations have arisen, exploring their own universe and perhaps even contemplating the existence of other universes, just as we do. The multiverse also raises the question of whether we are really alone in the grand scheme of existence. Even if we never make contact with intelligent life in our own universe, the existence of the multiverse suggests that we are part of a much larger reality where life, in some form, is almost certain to thrive. Quantum mechanics has not only revolutionized our understanding of the smallest scales of the universe, but has also opened up new possibilities for life beyond Earth. From the idea of the multiverse to the strange phenomena of entanglement and superposition, quantum physics challenges our classical notions of existence and suggests that the universe is far more complex and mysterious than we ever imagined. As we continue to explore the universe and search for signs of extraterrestrial life, we must be open to the possibilities offered by quantum mechanics. Life beyond Earth might not look or behave like anything we've ever seen, and it might obey the strange rules of quantum physics. Perhaps the key to discovering life lies not only in the stars, but in the quantum realm itself. In the coming chapters, we will further explore how quantum physics relates to the search for life and consider phenomena such as quantum teleportation, zero-point energy, and the potential for quantum communication across the cosmos. The quantum universe is a new frontier in our search for life beyond Earth, and it could hold the answers to some of the most profound questions about our place in the cosmos. Quantum communication, the key to reaching other civilizations? Is quantum teleportation a new form of instant communication? One of the most fascinating aspects of quantum physics is the phenomenon known as quantum teleportation. While the name may conjure up images of people or objects being transported instantly over long distances, quantum teleportation refers to the transfer of information, rather than physical matter, from one place to another using the principles of quantum entanglement. When two particles are entangled, their states are connected in such a way that any change in the state of one particle is immediately reflected in the other, regardless of how far apart they are. This enables the transmission of quantum information, or qubits, between 2 points without a classic communication signal having to cross the space in between. The impact on interstellar communication is enormous. Could quantum teleportation be the key to communicating with distant civilizations and overcoming the vast distances that currently limit our ability to send and receive signals? While quantum teleportation has already been demonstrated in experiments on Earth, where particles were teleported over distances of hundreds of kilometers, extending this technology to interstellar or even intergalactic distances remains a challenge. However, if we were able to utilize the principles of quantum entanglement on a cosmic scale, we might one day be able to send information instantaneously over long distances without the limitations imposed by the speed of light. Another potential application of quantum physics in the search for extraterrestrial life lies in the field of quantum cryptography. Quantum cryptography uses the principles of quantum mechanics to create secure communication channels that are virtually impossible to intercept. This is because any attempt to intercept a quantum signal would disturb the quantum state of the particles involved, which would make the interception attempt recognizable. In the context of interstellar communication, quantum cryptography could be used to ensure that messages between civilizations are secure and private. If an advanced civilization wants to communicate with Earth without the risk of other civilizations intercepting its message, it could use quantum cryptography techniques to encrypt its transmissions. This would offer a level of security that goes far beyond what traditional communication systems can provide. However, the application of quantum cryptography to interstellar communication raises interesting ethical questions about how civilizations might approach the ethics of cosmic communication. Would a civilization choose to keep its communication secret and use quantum encryption to ensure that only the intended recipient can decode the message? Or would it opt for open, transparent communication and send its signals freely through the universe? Looking to the future, one of the most exciting possibilities is the creation of a quantum internet, a global network of quantum devices that communicate with each other using entanglement. Researchers are already working to develop quantum networks on Earth, with the aim of enabling ultra-secure communications and advanced computing capabilities. But what if we extend this idea to the universe? Could we one day build a cosmic quantum network that connects planets, stars, and even galaxies with a vast system of quantum communication channels? Such a network would allow civilizations across the universe to exchange information in real time, overcoming the time delays that currently make communication across interstellar distances impractical. Theoretically, a cosmic quantum network could enable real-time communication between distant civilizations and allow collaboration and knowledge sharing on a scale previously thought impossible. This would revolutionize our understanding of the universe and could even lead to the formation of a galactic or intergalactic community of intelligent beings, all connected by the quantum fabric of space-time. While building such a network is far beyond our current technological capabilities, the idea that we could one day communicate across the stars using the principles of quantum mechanics is a tantalizing possibility. It suggests that the future of communication lies not in radio waves or lasers, but in the strange and counterintuitive world of quantum entanglement. Is zero-point energy a new energy source for interstellar travel? Quantum physics also brings into play the concept of zero-point energy, a form of energy that exists even in the vacuum of space. According to quantum theory, the vacuum is not really empty, but filled with energy fluctuations, even at a temperature of absolute zero. These fluctuations are known as zero-point energy and result from the uncertainty principle, which states that particles can never be completely at rest. Zero-point energy has long been a topic in both science and science fiction. Some researchers have suggested that if we could access this energy, it could provide a nearly limitless source of power that could potentially allow advanced civilizations to travel between stars. Could zero-point energy be the key to overcoming the vast distances of space and enabling faster-than-light travel or the construction of quantum communication networks? Even if the practical application of zero-point energy remains purely theoretical at present, it is worth considering the possibility that extraterrestrial civilizations are already using this energy. If they do, this could explain how they are able to explore the universe or send signals across light years without being bound by the same energy constraints we face. The concept of zero-point energy also raises questions about the nature of space-time itself. If the vacuum of space is filled with fluctuating energy, could this energy be used to manipulate space-time, bending or warping it to enable faster-than-light communication or travel? While these ideas remain speculative, they demonstrate the potential of quantum physics to open up new ways of thinking about interstellar exploration and communication. Is quantum telepathy a new frontier in cosmic communication? One of the most speculative ideas in the field of quantum communication is the concept of quantum telepathy. While telepathy, the ability to transmit thoughts directly from one mind to another, is often relegated to the realm of science fiction, some researchers have speculated that quantum entanglement could provide a mechanism for such communication. Quantum telepathy is about two minds being entangled in a similar way to quantum particles so that they can exchange information instantaneously, regardless of distance. If this were possible, it could revolutionize the way we think about communication, not only between individuals, but also between civilizations. Could advanced extraterrestrial beings communicate with each other, or even with us, through quantum telepathy, bypassing the need for traditional communication methods? While there is currently no scientific evidence for the existence of quantum telepathy, the concept raises interesting questions about the nature of consciousness and its possible links to quantum mechanics. Could consciousness itself be a quantum phenomenon capable of interacting with the universe at a fundamental level? And if so, could this offer a new way of communicating with intelligent life in the cosmos? Imagine if we had developed the technology to communicate across the cosmos using quantum entanglement. We would have built a quantum communication device that entangles particles on Earth with particles on distant planets, allowing us to send and receive messages instantaneously. Let's take this thought experiment one step further. Imagine that one day, while we are searching the cosmos for signs of intelligent life, we discover a quantum signal, not from our universe, but from a parallel universe. This signal contains information from an advanced civilization that has mastered quantum communication across the multiverse. They try to get in touch with us to share knowledge and insights from their reality. How would we respond? How would we even begin to understand the physics of their universe, which perhaps operates according to completely different laws than our own? And how would we ensure that our message reaches them, given the fundamental differences between our two realities? This thought experiment demonstrates the potential of quantum communication to bridge the gaps, not only between distant civilizations, but even between parallel universes. While the technology to achieve this remains speculative, the idea that we could one day make contact with intelligent beings across the multiverse opens up a whole new dimension of possibilities for the future of exploration and communication. Are we already being contacted by our search for quantum signals? As we continue our search for extraterrestrial life, most efforts are focused on detecting radio signals or other forms of electromagnetic communication. But what if intelligent civilizations used quantum communication instead? If they had mastered using quantum entanglement or other quantum phenomena to send messages through the universe, we might just miss their signals because we're not looking for them. Researchers are now beginning to explore the possibility that extraterrestrial civilizations could be trying to reach us through quantum communication. This requires the development of new types of detectors capable of detecting quantum signals, such as entangled photons that may be emitted by distant stars or planets. These detectors could look for subtle correlations in quantum measurements that could indicate the presence of an artificial signal. If we were to discover such a signal, it would revolutionize our understanding of the universe and our role in it. It would be direct proof that we are not alone in the cosmos, and that advanced civilizations are already exploring new ways of communicating across the stars. The discovery of a quantum signal would also force us to rethink our approach to the search for life and encourage us to develop new technologies and methods to detect and interpret these signals. As we continue to search for extraterrestrial civilizations, quantum communication offers a new frontier of exploration. From quantum teleportation and entanglement to the speculative possibilities of quantum telepathy and multiverse communication, the principles of quantum physics challenge our classical notions of how we might make contact with intelligent life in the universe. Even if many of these ideas currently remain purely theoretical, they demonstrate the potential of quantum mechanics to change our approach to cosmic communication. If advanced civilizations are already using quantum communication technologies, we may need to rethink our search for signals and extend our efforts to the detection of quantum phenomena. The future of communication with intelligent life may lie not in the transmission of radio waves or light signals, but in the strange and mysterious world of quantum entanglement. As we continue to push the boundaries of science and technology, quantum communication could one day provide the key to unlocking the secrets of the universe and connecting with civilizations far beyond our own. Quantum consciousness. Could life itself be a quantum phenomenon? For centuries, the nature of consciousness has puzzled scientists and philosophers alike. How do subjective experience, thinking, and self-awareness arise from the ordinary material of our brain? While neuroscience has made significant progress in understanding the biological mechanisms underlying brain function, some researchers have begun to turn to quantum physics to explain the mysterious nature of consciousness. Could consciousness itself be a quantum phenomenon, subject to the strange laws of the subatomic world? The idea of quantum consciousness suggests that our minds may be based on principles of quantum mechanics rather than classical physics. If this is true, the act of thinking and perceiving could involve quantum processes that take place in the microstructures of the brain, such as neurons and synapses. This theory has led to intriguing musings that consciousness may not just be a byproduct of neuronal activity, but a fundamental feature of the universe, a feature possibly shared by intelligent life throughout the cosmos. In this chapter, we will explore the possibility that quantum mechanics plays a role in consciousness, how this idea relates to the search for life beyond Earth, and whether extraterrestrial civilizations might have forms of consciousness radically different from our own. One of the best-known theories of quantum consciousness is the hypothesis of orchestrated objective reduction, OR, which was proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. According to this theory, consciousness arises from quantum processes in microtubules, tiny protein structures found in neurons. According to the theory, these microtubules could act as quantum computers and process information at the quantum level. OR is based on the idea that the brain operates in a quantum state in which superpositions of quantum states occur in the microtubules. When these superpositions collapse, consciousness arises as a result of this quantum reduction process. Penrose and Hameroff proposed that the collapse of these quantum states is not random but orchestrated, enabling the ordered experience of consciousness. Although the OR hypothesis is still controversial, it has aroused great interest in the scientific community. If consciousness is indeed a quantum phenomenon, this could suggest that life throughout the universe shares a common quantum basis. This opens up the possibility that other intelligent civilizations, even those with radically different biology, have a consciousness based on the same quantum processes that govern our minds. Is there a quantum phenomenon in the brain? Is the brain a biological quantum computer? The brain is an incredibly complex organ with trillions of synaptic connections between neurons, which is able to process huge amounts of information simultaneously. Some researchers believe that the brain's ability to cope with such complexity could be improved by quantum processes. In particular, the brain's ability to perform tasks such as pattern recognition, decision-making, and learning could be supported by quantum coherence and entanglement. In quantum computing, a qubit can exist in several states at the same time, which means that quantum computers can solve problems far more efficiently than classical computers. Could the brain function in a similar way and use quantum coherence to process information in a highly parallel way? If so, this would suggest that the brain is not just a classical machine, but a quantum system that can perform calculations that go beyond the limits of classical physics. Quantum coherence could also explain certain unexplained phenomena in neuroscience, such as the fast and efficient processing of information in the brain. For example, the process of olfaction, or the sense of smell, could involve quantum tunneling, which allows molecules to interact with receptors in ways that cannot be explained by classical physics alone. If quantum processes really do play a role in the brain, this would have profound implications for how we think about intelligence and consciousness in other life forms. It opens up the possibility that advanced extraterrestrial civilizations also rely on quantum processing to perform their cognitive functions, potentially giving them capabilities far beyond what we can currently imagine. Based on our understanding of quantum consciousness and extraterrestrial life, could aliens think differently? If consciousness is a quantum phenomenon, this opens up the possibility that extraterrestrial life has forms of consciousness that are very different from our own. Life on other planets may have evolved to use quantum mechanics in a way that is radically different from how the human brain works. An extraterrestrial civilization could, for example, use quantum computers on a much larger scale and thus be able to process huge amounts of information instantaneously or perceive reality in ways that we cannot imagine. One possibility is that extraterrestrial consciousness operates in a quantum superposition in which an extraterrestrial mind exists in multiple states simultaneously and only collapses into a particular state when it interacts with its environment. This could enable forms of intelligence that are far more flexible and adaptable than human consciousness, and capable of solving complex problems in a way that seems instantaneous to us. Another possibility is that extraterrestrial beings have developed the ability to manipulate quantum phenomena directly with their consciousness, allowing them to interact with the physical world in ways that transcend our conception of physics. If consciousness is truly rooted in quantum mechanics, the possibilities for extraterrestrial intelligence are almost limitless. The search for intelligent life beyond Earth has traditionally focused on the detection of technological signals such as radio waves or light from distant civilizations. But if consciousness is a quantum phenomenon, we may need to rethink our approach. Instead of looking for classical signals, we should consider the possibility that advanced civilizations use quantum communication. But what if extraterrestrial civilizations not only use quantum technology, but also operate with a fundamentally different form of consciousness? If extraterrestrial spirits are based on quantum processes, they could think, perceive, and communicate in ways that are completely incomprehensible to us. This could explain why we have not yet discovered any signs of intelligent life. Perhaps we are simply overlooking the signals because they do not correspond to our classical expectations. This idea also raises intriguing questions about first contact. If we were to come into contact with an extraterrestrial civilization that has quantum consciousness, how would we be able to communicate with them? Their thought processes could be so radically different from ours that conventional forms of communication would be ineffective. We may need to develop entirely new methods of interaction, perhaps even involving quantum entanglement or other quantum phenomena, to bridge the gap between our two forms of consciousness. Let's imagine a thought experiment in which an advanced extraterrestrial civilization has developed a quantum form of consciousness. In this civilization, beings are not confined to a single physical body, but exist in a state of quantum superposition that allows them to experience multiple realities simultaneously. They can process information over long distances using quantum entanglement, and their thoughts are not limited to a single timeline or physical location. In this thought experiment, these beings communicate not through speech, but through direct manipulation of quantum fields, sending information instantaneously across space. They perceive the universe as a series of overlapping probabilities and are able to navigate through different outcomes and select the one that best suits their needs. How would we interact with such beings? Their experience of reality would be so different from ours that conventional forms of communication would seem slow and clumsy in comparison. They could perceive time in a non-linear way, which would make it difficult for them to understand our sequential thinking. To communicate with them, we might need to find a way to tune in to their quantum consciousness so that we can exchange information directly without the need for language or symbols. This thought experiment demonstrates the possibility that consciousness in the universe could take forms far beyond our current understanding. If quantum mechanics is involved in the minds of extraterrestrial beings, our search for life may require us to expand our concept of what it means to be conscious and intelligent. Is there quantum immortality? Could consciousness survive death? One of the most fascinating and controversial ideas in quantum physics is the concept of quantum immortality. This idea comes from the many worlds interpretation of quantum mechanics, which states that every possible outcome of a quantum event occurs in a separate branch of the multiverse. According to this theory, a person's consciousness could split into several branches in a life-threatening situation, with one version of the person surviving in at least one branch of the multiverse. Although this idea is highly speculative and there is no experimental evidence for it, it raises fascinating questions about the nature of consciousness and its connection to quantum mechanics. Could consciousness persist in different branches of the multiverse, enabling some form of immortality? And if so, could this phenomenon also apply to other intelligent beings in the universe? If consciousness is indeed a quantum phenomenon, it could not be subject to the same limitations as physical matter. This opens up the possibility that advanced civilizations may have found ways to extend their consciousness beyond the confines of their physical bodies and possibly achieve a form of quantum immortality. Could extraterrestrial civilizations have mastered the ability to transfer their consciousness across the multiverse and thus attain eternal life? While the idea of quantum immortality remains purely speculative, it demonstrates the profound implications of quantum mechanics for our understanding of consciousness and the potential for life beyond death. If extraterrestrial beings have found a way to overcome the limitations of their physical forms, it could revolutionize our understanding of life, death, and the nature of existence itself. As we continue to explore the interface of quantum physics and consciousness, we are likely to gain new insights into the nature of life and intelligence in the universe. Quantum mechanics challenges our classical understanding of reality and opens up new possibilities for how life could emerge, develop, and communicate across the cosmos. In the coming decades, advances in neuroscience, quantum computing, and astrophysics could provide us with new tools to investigate the role of quantum mechanics in consciousness. These discoveries could revolutionize our approach to the search for extraterrestrial intelligence, as we begin to explore the possibility that life beyond Earth is governed by quantum processes that we are only beginning to understand. The idea that consciousness could be a quantum phenomenon also raises profound questions about our own existence. Are we just biological machines? Or is there something deeper, something quantum that creates our thoughts, feelings, and self-awareness? If consciousness is indeed rooted in the quantum world, we are all part of a much larger, more interconnected reality than we ever imagined. As we look to the future, the exploration of quantum consciousness could lead us to new discoveries about the nature of life, intelligence, and the universe itself. Whether we discover that alien civilizations share our quantum base, or that they operate in ways that are completely alien to us, one thing is certain: the quantum universe is full of secrets waiting to be discovered. Quantum mechanics and the possibility of faster-than-light travel, a way to travel beyond the speed of light? One of the greatest challenges of interstellar exploration is the enormous distances between stars and galaxies. Even at the speed of light, it would take over 4 years to reach our nearest stellar neighbor, Proxima Centauri, and hundreds of millions of years to reach distant galaxies. For this reason, much of the scientific community considers faster-than-light, FTL, travel to be impossible based on the laws of classical physics. Quantum mechanics, however, brings with it phenomena that challenge our classical understanding of space, time, and motion, and open up the possibility that faster-than-light travel may not be as unrealistic as once thought. In this chapter, we will explore how quantum mechanics, with its principles of entanglement, tunneling, and wormholes, could provide theoretical ways to circumvent the cosmic speed limit. Could the quantum world be the key to bridging vast distances in the universe? And if so, could advanced extraterrestrial civilizations already be using this method? In the quantum realm, particles can do something that seems impossible from a classical point of view. They can tunnel through barriers. Imagine throwing a ball against a wall, and instead of bouncing back, the ball simply goes through the wall, even though it doesn't have enough energy to do so. That is the essence of quantum tunneling. Quantum tunneling happens because particles such as electrons and photons are described by wave functions that indicate the probability of finding them at a particular location. If there is a barrier that the particle cannot overcome due to its energy, the wave function still has a non-zero probability of existing on the other side of the barrier. As a result, there is a chance that the particle will tunnel through, although this seems impossible by classical standards. Quantum tunneling is a well-established phenomenon that has been observed in laboratories, and it is critical to many technologies, including scanning tunneling microscopes and the nuclear fusion that powers stars. But could quantum tunneling also be an indication of faster-than-light travel? If particles can move through barriers without crossing the space in between, could a similar principle be applied to larger scales, allowing us to bypass the vast distances between stars? Although quantum tunneling has so far only been observed at the subatomic level, some researchers speculate that it could one day be harnessed for macroscopic objects. If we could develop the technology to manipulate quantum tunneling on larger scales, we could potentially tunnel through space and time, effectively jumping from one place to another without traversing the space in between. This could be a way to reach faster than light speeds without violating the known laws of physics. Another possible route to faster-than-light travel is via wormholes, theoretical structures in the fabric of space-time that could provide a shortcut between distant points in the universe. Wormholes, also known as Einstein-Rosen bridges, were first proposed in 1935 by Albert Einstein and Nathan Rosen as a solution to the equations of general relativity. A wormhole can be thought of as a tunnel through space-time that connects two distant regions via a shortcut. Theoretically, you could enter one end of a wormhole and emerge at the other end almost instantly, bypassing the vast distances that would otherwise take millions of years at the speed of light. Wormholes are often portrayed in science fiction as a means of interstellar travel, but remain speculative in the field of physics. Although the mathematics of general relativity allows for the existence of wormholes, they would require exotic matter with negative energy density to remain stable and traversable. This exotic matter would prevent the wormhole from collapsing and allow a spaceship or traveler to pass through safely. Quantum mechanics plays a role in wormhole theory, as it suggests that space is not smooth at the smallest scales, but is filled with tiny quantum fluctuations, sometimes referred to as quantum foam. Some researchers believe that wormholes could form naturally in this quantum foam, opening up the possibility of using them for faster-than-light travel. If advanced alien civilizations have found a way to stabilize these quantum wormholes and navigate through them, this could explain how they travel long distances in the universe without being limited by the speed of light. Can entanglement and non-locality enable faster-than-light communication? Quantum entanglement is one of the most fascinating and counterintuitive phenomena in quantum mechanics. When two particles are entangled with each other, their states are linked in such a way that the measurement of one particle immediately determines the state of the other, regardless of how far apart they are. This phenomenon, known as non-locality, has been experimentally verified and seems to imply that information can be transmitted instantaneously, faster than light. However, quantum entanglement cannot be used to send classical information faster than light, as the results of measurements on entangled particles are random. Although entanglement enables instantaneous correlations between particles, it does not allow the direct transfer of information that could be used for communication. Nevertheless, entanglement has a profound impact on our understanding of space and time. It suggests that the universe is interconnected on a level that transcends the limitations of classical physics. Some researchers have speculated that entanglement could one day be used for long-distance communication, especially if we discover new principles that go beyond the current limitations of quantum mechanics. In the search for extraterrestrial life, quantum entanglement opens up the tantalizing possibility that advanced civilizations could use quantum-based communication systems that bypass the limitations of classical signals. If such civilizations exist, they could communicate instantly across the galaxy or even across different parts of the universe without us knowing about it. At the heart of modern physics is quantum field theory, QFT, which describes how particles interact with each other via fields such as the electromagnetic field or the gravitational field. In QFT, particles are excitations in these fields, and their interactions are governed by the principles of quantum mechanics and relativity. Some physicists believe that understanding the quantum nature of space-time itself could lead to breakthroughs in faster-than-light travel. If space-time is made up of quantum fields, it might be possible to manipulate these fields to create shortcuts through space, similar to the concept of wormholes. One speculative idea is that advanced civilizations may have discovered how to manipulate the quantum fields that govern space-time to bend space or create areas of negative energy density that allow faster-than-light travel. This would require a deep understanding of both quantum mechanics and general relativity, as well as the ability to use enormous amounts of energy to manipulate the structure of space-time. Although this remains in the realm of theoretical physics, it shows the potential of quantum mechanics to play a role in the future of space exploration. If we could learn to manipulate the quantum fields of space-time, it could open up completely new possibilities for interstellar travel that are currently unimaginable. One of the best-known theoretical concepts for faster-than-light travel is the Alcubierre drive, a speculative idea proposed in 1994 by the physicist Miguel Alcubierre. The Alcubierre drive is based on the idea of creating a warp bubble that contracts space-time in front of a spaceship and expands it behind, allowing the spaceship to travel faster than light without violating the laws of physics. The key to the Alcubierre drive is that the spaceship itself never actually moves faster than light within its own local region of space-time. Instead, the drive manipulates space-time itself and effectively moves the space around the spaceship. This would enable the spaceship to travel long distances in a short time and bypass the light speed barrier. The mathematics of the Alcubierre drive is rooted in general relativity, but quantum physics also plays a role, particularly in the requirement for exotic matter with negative energy density. Some researchers have speculated that quantum fluctuations in the vacuum of space could provide the necessary exotic matter to stabilize the warp bubble and theoretically enable faster-than-light travel. Although the Alcubierre drive remains speculative and far beyond our current technological capabilities, it represents a fascinating interface between quantum mechanics and general relativity. If advanced alien civilizations have developed the technology to manipulate space-time in this way, it could explain how they travel between stars or galaxies without being limited by the speed of light. Imagine if an advanced civilization had mastered the technology to create and travel through stable quantum wormholes. They have built a spaceship capable of navigating these shortcuts through space-time, allowing them to travel instantly between distant regions of the universe. You are on board this spaceship and are preparing to travel through a wormhole that will take you from Earth to a distant galaxy millions of light years away. As the ship approaches the wormhole, you feel a slight distortion of space-time, as if reality is bending around you. The ship enters the wormhole, and for a brief moment everything goes dark. They are surrounded by the quantum foam of space-time, where particles appear and disappear, and time seems to have no meaning. Suddenly, you emerge on the other side of the wormhole, and the distant galaxy that would have taken millions of years to reach is now right in front of you. The journey took only moments, thanks to the manipulation of space-time and quantum phenomena. You have just traveled faster than light, not by crossing the room, but by bypassing it. This thought experiment shows the incredible possibilities that quantum mechanics offers for faster-than-light travel. While such technology is far beyond our current capabilities, it shows that the quantum world could be the key to unlocking the secrets of space-time and enabling travel once thought impossible. Is the future of faster-than-light speed a quantum dream? The dream of faster-than-light speeds has fascinated mankind for centuries, but quantum mechanics offers new hope that this dream could one day become reality. From quantum tunnels and wormholes to Alcubierre propulsion and the manipulation of space-time, quantum physics offers a wealth of possibilities for overcoming the limitations of classical travel. As we continue to explore the quantum realm, we may discover new ways of thinking about space, time, and motion that revolutionize our approach to space exploration. Although many of these ideas remain speculative, they remind us that the universe is far more mysterious and complex than we once thought. The quantum world challenges our classical understanding of reality and offers a glimpse into a future where interstellar travel is no longer a distant fantasy, but a real possibility. Quantum mechanics could also play a key role in the search for extraterrestrial life. Advanced civilizations could already be using quantum-based technologies to travel between stars, communicate over long distances, or even manipulate the fabric of space-time itself. As we continue to push the boundaries of science, we could one day unlock the secrets of the quantum universe and open up new horizons in the exploration of the cosmos. Quantum mechanics and the search for extraterrestrial intelligence. The question posed by the Fermi paradox: where are they? The search for extraterrestrial intelligence, SETI, has long occupied scientists and captured the imagination of people around the world. One of the most famous questions raised in this search is the so-called Fermi paradox, named after the physicist Enrico Fermi, who famously asked, "Where is everyone?" Given the vastness of the universe, with its billions of stars and planets, it seems statistically likely that intelligent civilizations should exist elsewhere in the cosmos. But despite decades of searching, we have not yet found any clear evidence of extraterrestrial life or intelligence. The Fermi paradox poses a dilemma. If intelligent life is common in the universe, why haven't we discovered it? A possible solution to the paradox could lie in the strange world of quantum mechanics. Could extraterrestrial civilizations use technologies based on quantum mechanics that we have not yet discovered? Or do they communicate in a way that challenges our classical notion of reality? In this chapter, we will explore how quantum mechanics could help solve the Fermi paradox and how it could inform our search for intelligent life beyond Earth. Traditionally, the search for extraterrestrial intelligence has focused on the detection of radio signals or other electromagnetic forms of communication from distant civilizations. The assumption is that advanced civilizations, similar to our own, would use radio waves to communicate over interstellar distances. However, radio signals are limited by the speed of light and are subject to interference, signal loss, and interference when traveling through space. Quantum communication, as discussed in earlier chapters, offers a potential alternative. If advanced civilizations developed quantum communication technologies, they could use quantum entanglement or other quantum phenomena to communicate instantly over long distances, bypassing the limitations of classical signals. This could explain why we have not received any radio signals from intelligent extraterrestrial life forms. They could be using quantum-based systems that we cannot currently detect. In quantum communication, entangled particles can share information instantly, regardless of the distance between them. Even if we don't currently have the technology to use quantum entanglement for faster-than-light communication, it's possible that advanced civilizations have found ways to harness these phenomena on a larger scale. If they do, we will have to rethink our SETI approaches and focus more on searching for quantum rather than classical signals. New tools for the search for quantum signals. If extraterrestrial civilizations use quantum communication, we need new tools to detect their signals. Traditional radio telescopes are designed to receive electromagnetic waves, but quantum communication could involve completely different forms of signals, such as entangled photons or subtle changes in quantum states. Recent advances in quantum sensor technology offer promising approaches for the future of SETI. Quantum sensors are incredibly sensitive devices that can detect changes in quantum states, such as shifts in the spin or polarization of particles. These sensors could be used to search for signs of quantum communication from distant stars or planets. By looking for unusual correlations in quantum measurements, scientists could identify artificial signals that point to the existence of an intelligent civilization. Quantum sensors could also be used to detect the presence of dark matter or other exotic phenomena that could be related to advanced extraterrestrial technologies. If extraterrestrial civilizations have found ways to use dark matter or other quantum-based energy sources, they could leave detectable signatures in the quantum realm, even if they do not emit classical electromagnetic signals. Using quantum computers to solve the Fermi paradox, one of the challenges in the search for extraterrestrial intelligence is sifting through huge amounts of data to identify possible signals. The universe is full of natural sources of noise, from pulsars to quasars to cosmic background radiation, and it is extremely difficult to distinguish artificial signals from natural phenomena. Quantum computers could play a decisive role here. As we explained earlier, quantum computers have the ability to process information far more efficiently than classical computers. With the help of qubits that are in a superposition, quantum computers can perform parallel calculations and explore many possible solutions simultaneously. This makes them ideal for analyzing the huge data sets generated by SETI searches. By using quantum algorithms on SETI data, researchers could search for complex patterns or correlations that indicate the existence of an intelligent signal. Quantum computers could also be used to simulate the conditions under which extraterrestrial civilizations might communicate, allowing us to predict what kinds of signals we should be looking for. In the future, quantum computers could revolutionize our ability to analyze cosmic data and help us identify subtle or hidden signals that would otherwise have gone unnoticed. This could bring us closer to solving the Fermi paradox and show us whether we really are alone in the universe. Quantifying the search. A quantum Drake equation. The famous Drake equation is used to estimate the number of intelligent civilizations in our galaxy with which we could potentially communicate. The equation takes into account factors such as the rate of star formation, the proportion of stars with planets, and the probability that life will develop on these planets. But the Drake equation is based on classical assumptions about life and communication that may not capture all the possibilities opened up by quantum mechanics. What if we were to extend the Drake equation to include quantum phenomena? For example, we could consider the likelihood that extraterrestrial civilizations have developed quantum communication technologies or use quantum-based methods for space travel. We could also include the possibility that life itself is based on quantum processes, as discussed in the previous chapter. This extended version of the Drake equation, let's call it the quantum Drake equation, would account for the role of quantum mechanics in the evolution of life and intelligence, as well as the potential for advanced civilizations to harness quantum technologies. By taking these quantum factors into account, we could arrive at a more accurate estimate of the number of intelligent civilizations in the universe, and also refine our strategies for finding them. Could quantum mechanics explain the rarity of life? One possible explanation for the Fermi paradox is the idea of the Great Filter, a hypothetical barrier that prevents life from evolving into advanced civilizations capable of interstellar communication. The Great Filter could occur at any stage of evolution, from the origin of life itself to the emergence of complex, intelligent beings. Quantum mechanics could provide new insights into the Great Filter. If consciousness or intelligence is based on quantum processes, it is possible that only a small fraction of life forms will be able to develop the quantum-based cognitive abilities necessary for technological progress. The complexity of quantum systems may be a barrier that few civilizations can overcome, which explains why intelligent life appears so rare in the universe. Alternatively, the Great Filter could lie in the ability of civilizations to use quantum technologies. Perhaps most civilizations never developed the knowledge or resources to manipulate quantum fields, communicate through entanglement, or explore the quantum nature of space-time. If few civilizations ever reach this level, it could explain why we have had no contact with extraterrestrial intelligence. Could quantum civilizations exist? Could extraterrestrial life exist in another reality? Another intriguing possibility is that extraterrestrial civilizations could exist in a quantum state instead of a classical one. As we have already explored in the chapters on quantum consciousness and quantum life, life in other parts of the universe could operate according to very different principles than life on Earth. If extraterrestrial civilizations have developed a deep knowledge of quantum mechanics, they could exist in a state of quantum superposition, inhabiting multiple realities simultaneously. Such quantum civilizations could free themselves from the physical limitations of classical civilizations. They could switch between different quantum states, navigate through parallel universes, or even communicate via the multiverse. If this is the case, we could miss their signals because we are looking in the wrong areas, in the classical world instead of the quantum world. Quantum civilizations could also have a completely different perception of time and exist in a non-linear way where past, present, and future are intertwined. This could make it incredibly difficult to communicate with such civilizations, as their reality is so different that we would struggle to understand their signals or intentions. A thought experiment. A quantum signal from a distant galaxy. Imagine a distant alien civilization that has developed the ability to communicate across the universe using quantum entanglement. Rather than relying on traditional radio waves or light signals, they use entangled particles to send instant messages across the galaxy. Their quantum network extends across star systems, allowing them to stay in contact with distant colonies or other intelligent species without delay. This civilization makes contact with Earth and hopes to establish communication. But their signals are encoded in quantum states that our current technology cannot recognize. From their point of view, they have been sending us messages for years and are waiting for an answer. From our point of view, however, we see nothing. No radio signals, no flashes of light, no indication of their existence. One day we will develop quantum sensors that are capable of detecting entangled particles from distant sources. One day we detect a signal that is unlike anything we have ever seen. It's not a radio wave or a light pulse. It's a series of quantum correlations that defy explanation. After years of research, we realize that the signal originates from a distant star system and represents the first direct communication with an intelligent, extraterrestrial civilization. This thought experiment demonstrates the potential of quantum communication to solve the Fermi paradox and the challenges of detecting such signals with our current technology. It also emphasizes the need to think beyond classical methods when we search for intelligent life. Conclusion: a new era of SETI research? As we progress in our search for extraterrestrial intelligence, quantum mechanics offers new opportunities and challenges. From quantum communication and quantum sensors to the potential existence of quantum civilizations, the strange and elusive principles of the quantum world could be the key to solving the Fermi paradox and helping us answer one of humanity's most profound questions: are we alone in the universe? The future of SETI research may require a shift in focus away from traditional radio signals to quantum phenomena. As our understanding of quantum mechanics continues to grow, we may discover new ways to detect signals, analyze data, and communicate across the vast distances of space. Whether we find extraterrestrial civilizations using quantum technologies or discover the quantum nature of life itself, one thing is certain: the quantum universe holds many secrets, and we are only just beginning to explore its full potential. Ultimately, quantum mechanics could not only revolutionize our conception of the universe, but also open up new avenues in the search for intelligent life and show us that we are part of a much larger, more interconnected cosmos than we ever imagined. Quantum time travel. Can we explore the past and the future? Why does time flow forward? One of the most fundamental experiences of our everyday lives is the constant flow of time in one direction. We perceive events in a sequence: past, present, and future. But as soon as we delve into the world of quantum mechanics, the nature of time becomes less clear. In classical physics, time only flows in one direction, from the past to the future, a concept often referred to as the arrow of time. Quantum mechanics, on the other hand, introduces uncertainties and flexibility into our understanding of time and raises questions about whether time travel or even communication between different points in time could be possible. In this chapter, we will explore the concept of quantum time travel and investigate whether quantum mechanics could provide a way to communicate with or even travel to the past and the future. Could advanced civilizations have mastered the manipulation of time and be able to send information forwards or backwards? Could time travel be the key to answering some of the most profound questions about the universe, including the possibility of intelligent life in different eras? One of the key principles of quantum mechanics is superposition, the idea that particles can exist simultaneously in multiple states until they are measured or observed. This principle challenges our classic understanding of time, in which events happen in a linear sequence. In the quantum world, particles may not experience time as we do. They may be in a state of superposition where they exist simultaneously in the past, present, and future. The quantum superposition opens up fascinating possibilities for time travel. Could it be possible that an entire system, or even a consciousness, exists in a superposition of different timelines? In such a scenario, an individual or civilization could experience multiple possible futures simultaneously and only collapse to a specific initial state when a specific decision or measurement is made. This concept of quantum timelines offers a new way of thinking about time travel. Rather than moving through time in one direction like a river, quantum mechanics suggests that time could be more like a branching tree in which multiple possible futures and pasts exist simultaneously in superposition. If we were able to manipulate the quantum superposition on a larger scale, we could potentially explore these alternate timelines and access different versions of the past and future. Quantum entanglement not only enables the connection of particles over long distances in space, but also indicates the possibility of connections over time. This phenomenon, known as entanglement in time, refers to particles whose states are correlated in such a way that they remain connected even if they are in different time periods. In conventional entanglement, two particles share information instantaneously, regardless of the spatial distance between them. But entanglement in time suggests that information could be shared between a particle in the present and a particle in the past or future. If this form of entanglement exists, it could open the door to communication across different points in time. Although the idea of entanglement over time is still speculative, it raises interesting questions about the nature of time itself. Could advanced civilizations use quantum entanglement to send messages into the past and change the course of history? Or could they receive messages from their future selves and use quantum communication to avoid disasters or make important decisions? If entanglement in time is possible, it could provide a method of exploring the past and future without the need for physical time travel. What question does quantum retrocausality raise? Can the future influence the past? Another fascinating concept in quantum mechanics is retrocausality, the idea that events in the future could influence events in the past. In classical physics, causality flows in one direction. Causes precede effects. In quantum mechanics, however, the relationship between cause and effect is less rigid, and some interpretations suggest that the future may play a role in shaping the past. One of the best-known experiments that points to retrocausality is the delayed choice experiment, a variation of the double-slit experiment. In this experiment, a decision is made as to how a particle should be measured after the particle has already passed through the slit. Surprisingly, the choice of measurement seems to retroactively determine the behavior of the particle, as if the future decision influences the past. Retrocausality challenges our classical understanding of time and causality and suggests that the future may have a direct influence on the past. If this phenomenon could be harnessed, it could provide a method of sending information into the past, allowing us to communicate with past generations or even alter historical events. Have advanced civilizations possibly found a way to use quantum retrocausality to navigate through time and send information along the timeline to influence their destiny? Although the idea of retrocausality remains speculative, it opens up new possibilities for time travel and communication across different eras. If the future can influence the past, this raises profound questions about free will, determinism, and the nature of reality. As discussed in earlier chapters, wormholes are theoretical structures in space-time that could provide a shortcut between distant points in the universe. But wormholes are not just limited to connections in space. Some theories suggest that wormholes could also connect different points in time and act as time machines, allowing travel to the past or future. Theoretically, a closed, time-like curve could be created by a wormhole, allowing a traveler to loop back in time and return to an earlier point in time. This idea is rooted in the general theory of relativity, which allows such curves under certain conditions. However, to traverse a wormhole through time, exotic matter with negative energy density would be required to stabilize the wormhole and prevent it from collapsing. If advanced civilizations have found a way to stabilize wormholes and use them for time travel, this could explain how they can explore not only space, but also the history of the universe. They may be able to observe or even interact with past civilizations and influence the course of history in ways we cannot currently comprehend. In such a scenario, time travel could become a tool for exploring the distant past or the distant future and gaining new insights into the development of the cosmos. One of the best-known problems of time travel is the grandfather paradox, a thought experiment in which a time traveler returns to the past and prevents his grandfather from meeting his grandmother, which prevents his own birth. This paradox raises the question of whether time travel is logically possible, as it seems to create contradictions in causality. Quantum mechanics offers a potential solution to time travel paradoxes such as the grandfather paradox. According to the many worlds interpretation of quantum mechanics, every possible outcome of a quantum event creates a new branch of the multiverse. If time travel is possible, a trip into the past could simply create a new reality in which the time traveler's actions affect only that branch and not the original timeline. In this scenario, time travelers could change events in the past without creating paradoxes. Instead of changing their own timeline, they would create a new timeline that branches off from the original one, allowing both versions of history to coexist. This idea suggests that time travel could be compatible with quantum mechanics as long as we accept the existence of multiple parallel realities. Could advanced civilizations have found a way to navigate between these quantum branches and use time travel to explore alternative versions of history without causing paradoxes? If so, they might be able to observe or interact with different versions of Earth's past, the future, or even alternate realities where different outcomes have occurred. Imagine if scientists had found a way to send information back in time using quantum retrocausality. They would have built a device that can transmit quantum states to their past selves, allowing them to send warnings of potential disasters or important discoveries that could change the course of history. In this thought experiment, you are a researcher working on this quantum time communication project. One day you receive a quantum signal from the future that contains information about a decisive breakthrough in physics that has not yet been made in your time. The signal explains a new theory that will revolutionize your field and provides detailed instructions on how to perform the necessary experiments. As you follow the instructions, you realize that this new theory could change everything. It could lead to new technologies, new forms of energy, and even the possibility of faster-than-light travel. But as you make these discoveries, you begin to ask yourself, who sent the signal? Was it your future self or a future generation of scientists? And how does receiving this information change the future that sent it? This thought experiment highlights the potential of quantum retrocausality to bridge the gap between past and future, allowing us to communicate across time and potentially change the course of history. Although the idea of sending messages through time remains speculative, it challenges our classical understanding of causality and opens up new possibilities for exploring the nature of time itself. In recent years, physicists have discovered a new phase of matter known as time crystals, which exhibit a strange kind of motion that repeats itself in time rather than space. Unlike ordinary crystals, which have a repeating structure in space, time crystals have a repeating pattern in time, which means that they can be in constant motion without using energy. Time crystals are an example of how quantum mechanics challenges our classical understanding of time and motion. They raise the intriguing possibility that time itself could be manipulated or controlled in ways we do not yet fully understand. Could time crystals be used to develop new technologies that enable time travel or communication across time? Could they provide insights into the quantum nature of time and help us unravel the mysteries of time travel? While time crystals are still a relatively new discovery, they represent a significant advance in our understanding of quantum mechanics and its relationship to time. As researchers continue to study these exotic forms of matter, they may discover new ways of thinking about time travel, time loops, and the manipulation of time on a quantum level. Quantum mechanics has revolutionized our understanding of the universe, and one day it could do the same for our understanding of time. From quantum superposition and entanglement through time to the possibility of retrocausality and time travel through wormholes, the quantum world offers a wealth of opportunities to explore the past, present, and future in ways once thought impossible. As we continue to push the boundaries of science, we may discover new ways to manipulate time, allowing us to communicate with the past, explore alternate timelines, or even travel through history. Quantum mechanics challenges our classical notions of time and causality and opens up new horizons for discovery and exploration. In the search for extraterrestrial intelligence, quantum time travel could offer a new perspective on the Fermi paradox. Perhaps advanced civilizations have already mastered the ability to explore time by using quantum technologies to observe or interact with other epochs in the history of the universe. If so, they could be watching us from the future or the past, waiting for the moment when we unlock the secrets of quantum time travel and join them in exploring the full scope of space and time.